Hello everyone. So today's video is about what is DeFi. And before we can get into DeFi, we want to make sure that we understand the difference between private keys and public keys and how they work. So if you think of, say, the blockchain being a series of interconnected computers, that's what they really kind of are, right? Now, each computer contains the entire transaction history / ledger. Now, when we talk about spending your Bitcoin, what we're actually saying is you are going to this node and trying to authorize you spending money on the network itself. Good question. What is a node? So, a node is essentially just a computer run by people, but you can think of it as the representation of someone or an organization within a computer network. It's just a piece of software that runs. There's nothing more to it, but the software can be any kind of software. In this case, in a blockchain network, each node runs the blockchain client software. We'll just call that. So, going back, we now, as a user, want to spend money by authorizing a transaction, and we send our authorized transaction to some random node on the network. So, what this actually means is that we have to use our private key to authorize this. So, a private key is essentially just a really long string that's unique to you. And if anyone else finds out your private key, they can basically spend money on your behalf. And each private key will then correspond to a relevant public key. A private key is, I don't know exactly, but it's pretty long. Yeah, it's just a bunch of random characters. And a public key is essentially a bit shorter than a private key, but they all look like gibberish. They always start with 0x something something something. Right, so the difference between a private key and a public key is a private key allows you to authorize transactions on the network, and this is something only you know. If you tell this to anyone, they can authorize transactions on your behalf. Whereas your public key is something you share with everyone. So this allows someone to send money to you, and then this allows you to spend money as yourself. So, moving on now. As long as you hold your private key, you're in control of your funds. Now, the first kind of thing which people wanted to do when crypto came out was essentially trade cryptocurrencies. That's what everyone wanted to kind of do after a while. And the way that they had to do this, because an exchange needs to match orders between two parties. So let's say we have Bob here and Fred here, and he says, I want to sell 1 ETH, and Fred says, I want to buy 1 ETH. Both of these parties actually have to come together and essentially meet in a digital world somewhere. And this bit in the middle is what we call an exchange. And the way that the exchange actually works is Bob has to actually send his Bitcoin to the exchange, and Fred needs to send his Bitcoin to the exchange. And what that means is that the exchange now owns their Bitcoins because the exchange is in control of the private key. How do they send it to the exchange? They just authorize a transaction they essentially create a transaction that says send to exchange. They sign it with their private key, and then they send it to a node. So that's the entire flow of a transaction. So now what's happened is Bob and Fred have let go control of their private key. They've let go of custody of their funds and given it to the exchange. They're now trusting the exchange won't run away with their money. And they're hoping that by the time they want to take their money back, the exchange still has the money. And this is kind of the core of the problem which DeFi addresses. It removes the problem where we have to trust another party in order for us to do business together. That is like the most essential value proposition of DeFi. So how does it do that, right? To put it simply, how does DeFi enable no trust? And the simple answer is through smart contracts. Okay, good question. So smart contracts, a lot of people think of them as like a, what do you call it? Like I say, legal digital contract, or that's kind of like the first word which people think of, but that's like absolutely not how you want to think of them. Instead, what a smart contract really is it's a program that runs on the blockchain. So this program is uploaded directly to, say, the Ethereum blockchain. And once you upload this program, it can never be changed. It will keep on running forever. Okay, so the person who uploads it to the Ethereum blockchain, it can technically be anyone. So each program will have a writer and then someone who uploads it. Usually the writer can upload the program itself, is the one who uploads the program, but it means that anyone who has this code can then upload it to the blockchain again, meaning you have multiple copies of the same program on the blockchain. And the blockchain, once it's on this thing, it can essentially never be changed. That's the most fundamental thing about these programs. Now, what also makes these programs really special is that they can handle money without any humans or businesses requiring you to hold your funds. So let's go back to the previous example where we have where we have Bob who wants to sell 1 ETH, and we have I forgot his name, but let's just say he was called Tyson, who wants to buy 1 ETH. Now, instead of there being this exchange in the middle, one developer can essentially write a smart contract or a program that lives on the blockchain. One second. Okay, a smart contract is written through a special programming language, but we won't get into the details of that in this episode. So anyway, going back, the smart contract written by this programmer, it can essentially create rules by saying that if I get authorization that Bob wants to sell, and I get authorization from Tyson that he wants to sell, I can execute this trade on their behalf, and how I execute that trade will be written in these lines of code. Now, of course, I will temporarily receive these funds, so the funds will go from Tyson to the smart contract to Bob, and Bob from the smart contract to Tyson. But the beauty of this is that both of us can see what's written inside the smart contract, and we don't have to worry about anything going wrong unless the code is correct. And that's essentially the whole value proposition of DeFi, that we can do financial transactions without having to rely on any person to do the right thing. We can write all of the rules inside the code, and the code will execute it on our behalf. So let's maybe take some of the popular DeFi use cases which we see today. So I think the biggest one which we're kind of seeing right now is lending / borrowing. And the way a lot of these lending / borrowing protocol works is that you can have a lender, you can have a borrower, and the lender can put money in the pool and the borrower can pull money out of the pool, and the interest rate is calculated by the contract itself. And I won't get into too much of how this works, I'll save that for another video. But the basic idea is, for the first time, rather than trusting a bank which will pay us interest and whatnot, the bank is the code itself. And unless the code is doing what we don't want it to do, we can always be certain that the code will meet our expectations. And that's the whole thing around DeFi. Now, DeFi is the term itself is a bit misleading, because it technically means decentralized finance. Now, as we said before, you can either, in our typical exchange example, which we talked about over here, we kind of had two problems. One was that we lost custody, as in we don't control our funds. And the second is that someone else can use special powers to steal money. Now, the thing about a lot of DeFi applications, they will always cover this first one. That's kind of like the main thing, which you'll get if you use DeFi. But the second one isn't always true. And the reason for that is that these protocols are still fairly new, and there's teams working on them that need special permissions to change the code itself. So let's say they wrote V1 of this program, but then there's a little bit of an error. They need to be able to have a special key to change the code to update it correctly. But the really cool thing about DeFi is that anyone can see what permissions the administrator has to change. How do they get the special key? They just specify it within the code. So they say, I can use a key here to change this function, essentially. So let's say in the case of our lending protocol, if they want to make an upgrade that changes the way interest is calculated, anyone can see the fact that the administrator has a way to change the interest, and that's the really good thing, because you can actually quantify how controlled is this protocol. But the risk is that they always can still be controlled. And the one thing which kind of makes this safer is that sometimes these administrators, rather than being individual keys, can actually be another smart contract itself, which means that there's a program which determines whether an administrator can change the protocol. And the most common, when we talk about, say, admin keys in DeFi, we either have this is like someone's private key, This is really dangerous because what this means is that one single person can use his key to change something in the protocol. Whereas the safer option is what we called a multisig. And a multisig essentially means that multiple private keys need to sign off on a single transaction before it goes through. And then an even more secure version of the multisig is a time delay multisig, where there's, say, a 3-day delay. So all the signers have to approve, and then they have to say wait 3 days, and then the transaction goes through, meaning everyone on the network can see that there's a change happening. They can see what the change is, and then they can decide whether they want to take their money out or not. And that's kind of like the whole beauty around DeFi, that for the first time we can simply read the code to see how much control someone has, and whether they're going to change the rules on us. This isn't kind of, say, like the Federal Reserve, which says, hey, we're going to print $2 trillion tomorrow. Unless the code specifies that the administrator can print $2 trillion tomorrow, there is literally no way that they can. And that, I hope, presents the value of DeFi. No problem. Is there anything else? Cool. I hope you guys enjoy this, and look forward to seeing your comments about this below.